Welcome back to Module 11 as we get into our very last Alabama-specific lesson. Every now and again, the textbook has to create a special lesson just to make sure you've covered everything in the Alabama course of study. The lesson today is on mean and mean absolute deviation. They claim it's going to be a one-day lesson. It only has 10 resources. Let's get into it. Unlike the life expectancy of predatory cats, the life expectancy for wild dogs has less variation. Wild dogs are part of the animal family Canidae, and for biologists it might be important to find out more about the variation using a different measure of variation to study it. The data for the life expectancy of the wild dogs from the animal family Canidae don't have a large variation. Don't just doesn't work there. I think it should be doesn't. Even though it's the same, I get it, but don't work. Describe how the box plot of this data would look. And you can see here when they go through these different animals in this family, you've got a range of 10 to 15 years that they're looking at. What that other data form is they're talking about, that's part of what we're going to learn about in today's lesson. In a previous grade, you learned using measures of center, otherwise known as, I can't remember the other term for it now, such as the mean, the median, to describe the center of a numerical set of data. Recall that the mean, or average of your set of data, is going to be the sum of that data divided by the number of data values. Suppose you had 4 tests scoring an 86, a 90, a 70, and a 94. You can find the mean by adding those test scores together and then dividing that total number by 4. Moving on from there, you can see that the mean is most often referred to as the balance point of the data. You know, I have never heard it. They says most often referred to that. I have never in my life heard it referred to as the balance point in the data. That's a brand new concept to me. The data plot shown displays the test scores. To determine the balance point of the data set, the total distance between the mean, total values below the mean and the mean must be equal. Let's try that again. To determine the balance point of the data set, the total distance between the values below the mean and the mean must equal the total distance between the values above the mean and the mean. That's kind of confusing, isn't it? Let's see if they'll clarify that a little bit. Here it says the distance between the value below the mean is 15. So you've got from here to the middle is going to be 15. And the mean is equal to the sum of the distances between the values above the mean. So you've got 9 plus 5 plus 1. 9 plus 5 plus 1 is equal to 16. 15, excuse me, I'm sorry, 15, so there you can see you've got 15 above the mean too. So there you go, your balance point from the lowest, you only had 1, from that lowest point to the mean, it was 15, and then when you add up all the points above, how far they are from the mean, that added up to equal 15 as well. Alright, can you tell this is the first time I've seen some of this? I have honestly never dealt with this before. It makes total sense when you look at it because of how it all works, but this is a brand new approach to me that I have never seen before. Let's keep going and see what other new stuff they have for us. Using the mean as a balance point, what are you trying to balance? You're trying to balance the data so that you have even amounts of data on both sides. If you went back over here, you had 15 points of data over here, and you add all these up, you have 15 points worth of data on that side as well, so they have the same weight in data on both sides. I've just never seen it shown that way. It's pretty cool, really. For example 1, the table shows the recorded high temperature in degrees Fahrenheit for 6 days in Huntsville, Alabama. That's fairly close. Find the mean temperature and summarize the data. So you can see that this is high temperatures, so that must be in the middle of winter time of 54, 42, 41, 46, 46, and 41. And it says to find the mean and to summarize the data. Without calculating the mean, you might be able to balance the data with a data set, explain your reasoning, probably, but it would be pretty complicated to do. Let's keep going here. So we're going to move through the steps to find the mean. First off, how many data values do we have? We have 1, 2, 3, 4, 5 data values that they've given us. So we have 5 data values we need to look at. Check that. Hold on. How many data values are in the set? Let me go back and look at the original problem. We have 1, 2, 3, 4, 5, 6. My bad. We have 6 data values in our set. Try again. Now that part's good. Next question we have is to take and find the mean, which means they added up each one of those data values, divided by 6, which is the number of data values, and that gave them a mean or an average temperature of 45 degrees. From here, you can see it says the mean or average temperature, high temperature for the selected days is going to be 45. Hit check, and that part checks. Next, if you were to take and look at a dot plot, it confirms that the mean temperature is going to be 45 degrees. And this is why. You have one plot that one point is 3 points away from the mean, 2 points that are 4 points away from the mean, and when you add that, 4 plus 4 plus 3 is equal to 11. And then we go the other side, you have 2 points that are 1 point away from the mean, and 1 point that is 9 spaces away from the mean, and that gave you 9 plus 1, which is also 11. That means that the data on both sides, if you add them up, are going to be the same exact distance from the mean. That means that tells you that the mean you selected is of 45 is going to be the true mean for this problem. From here, we can take out, that's just the original problem. All right, I do believe we're good with that one. Now it's going to be time to see if you can do that on your own. We're going to move on to extra example number 1, where you're going to pause the video. They want you to take and find out what the mean or average is going to be of this data. They don't even ask you to plot it. They just need you to find the mean. The amount Ari earned mowing lawns each month for the past 5 months was $150, $150 again, $125, and $75. So to find the mean, we're going to take and add those values up. 100 plus 150 plus 150 plus 125 plus 75. And we're going to divide that by the number of data values, which is going to be 5. So let's see here. We're going to have 200 plus 300 is 500, 600. That's going to give me 600 divided by 5, which means that the average, I think I did something wrong here. Nope, the average is going to be $120. If I did that right in my head, let's take a look and show you how I did that. 5 goes into 6 1 times. 1 times 6 is 5 with 1 left over. Bring down your 10. 5 goes into 10 2 times. 2 times 5 is going to be 10 with nothing left over. Bring down that 0. 5 goes into 0 times. That's where the 120 came from. Pretty easy to do, right? No problem at all doing this math. Jumping back into our textbook, we're going to type in that 120, check our answer, and the answer checks. Easy math. Now we're going to get into the concept of mean absolute deviation. And I can honestly say, prior to getting this textbook, I never ever used this. It tells us that you have learned how the range and the inner quartile range describe the spread of data, and what they're talking about there are the box and whisker plots that we've done. Another measure of variation is the mean absolute deviation. The mean absolute deviation of the data set is the average distance between the data value and the mean. The lower the mean absolute deviation is for the data set, the closer the data values are to the mean. Okay, that's a lot to take in. They're going to give us some examples to help explain that. Here we have an animation which we get to look at.
The table shows the number of points scored by a basketball team in 6 different games. Find the mean absolute deviation of the number of points scored. To find the mean absolute deviation, start by finding the mean of the data set. Calculate the sum of the values in the data set. and then divide by the total number of values. Next, find the distance between each value and the mean. One way to do this is to plot the mean and the data set on a number line. Then find the distance between the mean and the first value. Use the same steps to find the distance between the mean and each of the other data values. Next, find the mean of the distances. Find the sum of the distances. Divide the sum by the number of distances. The result is the mean absolute deviation of the data set. In this example, the average distance each data value is from the mean is 4 points per game.
Alright, so there that is. I think I have used this once upon a time when looking at special ed testing to see if people qualified for special education classes, but it's not something I use a lot. So let's look at example 1. The table shows the maximum speeds of 8 roller coasters. Find the mean absolute deviation of the data set and explain what the mean absolute deviation represents. As they showed us in the example, the first thing we have to do is find the mean or the average of the data set. And when you do that, we're just going to take, because we've got a lot of data here, let's just use our calculators. So I have 58 plus 88 plus 40 plus 60 plus 72 plus 66 plus 80 plus 48. All that adds up to equal 512, and we're going to divide that by 8 to get 64. So the mean or the average speed of those roller coasters is going to be 64 miles per hour. Next, we're going to take and hopefully put that on a graph. So you can take, and it says find the distance between the value of the mean, and then select the graph data to graph the points, and then select and find the distance between the Try that again. Then select the distance to find the distance between each data value and the mean. So first thing we're going to do is graph the data points. So here's all your data points we have, and the mean we said was 64, so that mean is going to be located right about here. I believe it's going to be our 64 point. Next, we want to find the distance between that 64 and all the data points. So when we do that, you can see that 60 is 4 away. So this next one here is going to be 58 is 6 away. Over here, 48 is 16 away, and 40 is 24 away. On the right-hand side, we have got 66 is 2 away, 72 is 8 away, 80 is 16 away, and 90 is 24 away. When you're doing that on paper, it's going to take some time, folks. Be patient with yourself as you're doing this, because it's going to take a few minutes. Now, we're going to have to take all these distances on the left and all these distances on the right, add them all up together and divide by the number of data points. So, when we do that, we add all these together and it came out to equal 100. That's a nice friendly number. And then 100 divided by 8 gave us 12.5, which means the mean absolute deviation is going to be 12.5. So what does that mean again? The mean absolute deviation is 12.5 miles per hour, and that means that the average distance each of the roller coaster speed is from the mean is going to be 12.5 miles per hour. Some of them are going to be farther from the mean, some of them will be closer to the mean, but the average distance they are from the mean is going to be 12.5. Now it's going to be your turn. Pause the video and find the mean absolute deviation of this set of data about the maximum speed of 10 birds. Alright, first thing I did is find the mean. To find the mean, I took and added up all of my numbers that were in the data set, and then I divided by the number of numbers that were 10, and that gave me the average speed, or the mean, of 78.6 miles per hour. Sure would have been nice if they gave us an easier number to work with. Alright, the next thing I did is I created a number line. On my number line, I plotted that center point, the mean of the data, which was 78.6. Next, I'm going to plot all of my points, which means I'm going to take a 65 right here, knock that one out, another 65, knock that one out, a 70, knock that one out, and now each one of those points are plotted. Now I have to find out what the distance is from each one of those points and our mean. So let's start here close, and that one is going to be a mere 1.6 away. This one right here going that direction. Let's do a different color, try and clear things up a little bit here. So for that one, going to our mean, run that mean line on down, 1, 2, 3, 4, 5.6. So that is going to be a 5.6 away. The next one, we'll go ahead and use a green, is going to be how far away? Well, that was 5, 6, 7.6. Next, we'll go to the other side. So for the other side, what am I going to do? Well, I'm going to take and start counting down. I'm going to go 1, 2, and that's 0.4. So my first distance is going to be a 2.4. And this one here, that one's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and this one to go beyond that, 11, 12, 13, 14, 15, 16, 17, 18, 24. I want to lay that over here, that one's going to go 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, right there, 24. Now I have all of those data sets created, how far each one of those points are from the mean. The next thing I'm going to have to do is take that information and average it. So I'm going to start off with my hard left here, where I've got a 12.6 plus another 12.6 plus a 9.6 and all of that information is going to be divided by 10. That's a calculator problem. So now I'm going to bring in my calculator, which is right here, and I'm going to start adding all those values up. So I had 12. After working this problem, I realized I'd screwed up. So I went back and looked at it and found out that my distances were all wrong here, largely because I put 78.6 in the wrong spot. It should have been right here. So let's add all this up and find the average now. Which is my right down here, 109.2 divided by 10. That's going to end up equaling 10 and 92 hundredths. Jump back over and see how close I am what the textbook said. You can see right there the textbook said the same thing. That is going to be the mean absolute deviation. Now I can take and put that number right here as well. 10.2 miles per hour is going to be the average distance that each data value is going to be from the mean. We're almost there. I know this video is getting long. Hang in here with me. We have to now learn how to compare two mean absolute deviations. Two driver schools use the same practice driver's test. Out of 100, School A had scores of 70 yada yada, and School B have scores of 77 yada yada. Find the mean absolute deviations and then compare the values. Now they're not going to make you find them, they're giving it to you. So School A had a mean of 81.2 and a mean absolute deviation of 5.84. Meanwhile, School B had a mean of 81.2 and a median absolute deviation of 1.76. If you don't remember how to do that, the instructions here will tell you what to do, or you can just go back and watch the video from before. So you can see that both of these have the same mean or average score, but this one, the data values were further apart than this one. Moving on to the next part, we can say that the mean absolute deviation for School A is going to be greater than for School B. This means that the scores for School B are going to be closer together and clustered around the mean. The schools for School A are going to be more spread out and not clustered around the mean. That's all there is to doing this. It helps you to interpret the data and get a better idea of what's better. I'm thinking School B does a better job of preparing their students because the majority of them are all clumped together right there in that same mean absolute deviation. All right, This is it, the last piece for you. The running times of 5 movies are so-and-so. The running times for 5 drama movies are so-and-so. Find the mean absolute deviation and compare them. You know what? I'm not going to make you do that. We've already learned how to find all this information. We've found the mean, we found the mean absolute deviation, and we have compared them. I'm not going to have you sit there and calculate all that stuff again, and neither am I. I think we spent enough time here. Y'all get started on your homework, and we will talk about this more in class tomorrow when you have questions. See you in class.